Children, we start with one of the very important concepts of chemistry, that is how to balance a chemical reaction. Very quickly we go through the 9th standard's important law, which was law of conservation of masses. The law stated that the mass of reactants should be equal to the mass of products, right? In a chemical equation, if the masses on both the sides is not balanced, then we can definitely balance it by a method which is called balancing a chemical equation. Done? So, let's take example of this reaction when magnesium is burnt in air to form magnesium oxide. If you calculate the mass of reactants, 1 magnesium and 2 oxygen give you a total mass of 56 U. But when you look at the product side, magnesium and oxygen have 1 atoms each and the mass comes to 40 U. This reaction here is an unbalanced chemical equation, and the first thing we will have to do is we will have to make sure that the number of atoms of magnesium and oxygen on the reactant side and on the product side should become equal. And this is what we do in a chemical reaction balancing, where we try to make the number of atoms of elements on both the sides same. The technique or method used is called hit and trial method. Important objective, remember the method of balancing a chemical equation is called hit and trial method, and by using this technique we will ensure that first we will make the number of atoms equal on both the sides, which will definitely create equal masses. Okay? How to balance a chemical reaction? Let us start with first reaction. Magnesium reacts with oxygen O2 to give MgO. First step, you will make a box around the names of reactants and products. What does this mean? Any number when you are adding, you are not supposed to make any changes inside. Means यहाँ पर पीछे कोई भी numbers add नहीं करना है. While balancing, you are allowed to write a number only at the position before the name of the reactant or product. Okay. Now make a box and write the names of all the elements which are taking part in this chemical reaction, like magnesium and oxygen. Count the number of magnesium on the reactant side, 1, correct? And number of magnesium on product side, 1. Number of oxygen atoms on reactant side, 2. And number of atoms of oxygen on product side, 1. Now, the place where you see that the number is not balanced, you can start from there. This is one of the easiest examples for which we have started with. We can easily make sure that यहाँ पर in front of magnesium oxide, we should write a 2. Why? Because when you write a 2 in front of the compound, this 2 means there are 2 atoms of magnesium and 2 atoms of oxygen. Maths में जैसे distributive property follow करते हैं, same here in science. This 2 is a common number, which means there are 2 atoms of magnesium and 2 atoms of oxygen. So now by doing so, we have balanced the oxygen on both the sides. Now when you look at the reactant side, there is only 1 magnesium, correct? So we will write a 2 here. This means now how many atoms of magnesium on reactant side? 2. Now very carefully look at the whole reaction and just check out 2 magnesium, 2 magnesium, 2 oxygen, 2 oxygen, and the reaction is balanced. Now we come to one of the most important reactions often asked for balancing even in your boards. How do we start it? See, iron when reacts with water, it forms Fe3O4 and hydrogen gas is released. Let's count the number of each element on both the sides. There is 1 iron atom in reactant side and there are 3 atoms of iron on product side. There are 2 hydrogen atoms on the reactant side and 2 hydrogen atoms on product side. There are 1 oxygen atom is on the reactant side and 4 oxygen atoms are on the product side, right? In this case, generally you should start with the element where the number is most unbalanced. But in this equation, you can also start with iron. Now look, there are 3 atoms of iron here. What we can do is, we can come here and we can write a 3 here. This shows that 3 atoms of iron on reactant side are balanced with 3 atoms of iron on the product side. So here we balance the number of iron. Now come to oxygen. Here we have 4 oxygen and here we have only 1 oxygen. What you can do is put a 4 here. In front of water write a 4. Now what happens is 4 will get multiplied with both hydrogen and oxygen, which means 4 twos are. How many hydrogen are there on the reactant side? 8. And 4 ones are, so how many oxygen are there on the reactant side? 4. So you can simply change this equation by writing 4 molecules of water. When you calculate, just see, 4 twos are 8 hydrogen and 4 ones are 4 oxygen. So we balanced the oxygen also. But while we were doing so, we have changed the number of hydrogen here to 8. 4 twos are 8. But when you look on this side, how many hydrogen are there? Only 2. Now the last change which you will have to make is put a 4 here on the product side. See, 4 twos are 8. Now carefully look at the reaction. 3 atoms of iron here, 3 here. 4 twos are 8 hydrogen here, 4 twos are 8 hydrogen here, and 4 ones are 4. 4 oxygen here, here also 4, and our reaction is balanced. Children, one more important thing. Whenever this reaction is asked in exam, kindly learn the states. Here iron is in solid state. Hydrogen, water is always taken as steam here. Very important objective to be remembered. Iron can react with water only in the gaseous state. Here again a solid is formed and water is a liquid. Mostly remember this part. Iron reacts with water only in the gaseous state. So if after balancing you are asked to write the states, rest of the states are quite clear, you have to be sure that your water is taken as steam.